In this video, we're going to talk about applications of rational equations, but we're going to really focus on two in particular. First is called a work rate problem. So the idea with a work rate problem is if we have two things working together, they should be able to finish a job faster. So for instance, if we have one pump that can fill a swimming pool in 6 hours and another pump that can fill the swimming pool in 9 hours, how long is it going to take them working together? Okay. So that's what we're going to do first is define our x, our variable in this problem. And in this case, x is going to be the time working together. Okay. Now, as a concept, or I should say, in general, when we do word problems, you have to include this step where you define your variable. You tell me what your variable represents, okay? That is required. All right, but let me talk to you about how we're going to find our answer. So the idea here is we're talking about how quickly a pump can fill the pool. And what we're going to do is we're going to think of their rate per hour. So how long it takes them to fill the pool every hour, how much of the job is done. So for the first pump, since it can do the job in 6 hours, that means after 1 hour, 1/6 of the job is done. And then in the next hour, another 1/6 of the job is done, or 2/6. And then the next hour, 3/6, or half the job, right? The idea is every hour, the pump completes another 1/6 of the total job. That's the hourly rate then for that pump. For the second pump, it takes 9 hours, so 1/9 of the job is done. And then 2/9 after another hour, and then 3/9 and so forth, okay? So together, I don't know what the time is, but it would be 1 over x, whatever x is. And I'm going to use this information to create an equation. So I'm going to take the two rates, and the rate of the first pump plus the rate of the second pump should equal the rate for them together, how fast the job is finished together. And I have to do it this way because I'm talking about their speed of finishing the job. So I'm thinking of it as a speed. And when two of them are working together, they'll combine their speeds together to get a faster speed. Okay, that's the idea. Okay, but to solve this equation, we're going to need to do the clearing the fractions, an LCD. So let's do that. So for this, 6 and 9 have 18 in common, and then we also have an x. So I'm going to multiply everything by 18x. So I'm left with, on the first fraction, 6 is going to go into 18 3 times. And that 3 times the 1 is going to just give me 3, and there's still the x. Plus, okay, so for the next one, 9 is going to go into the 18 2 times. So 2 times the 1 is 2, and there's also an x. For the last one, the x cancels completely, and we're just left with equals 18. All right, so 3x plus 2x is 5x, and dividing both sides by 5. Plug that into the calculator, you're going to get 3.6. And since this is their time working together, that would mean 3.6 hours. They're going to finish the job in 3.6 hours if they work together. That totally makes sense. It should take less time than the fastest pump, right? If the fastest pump does it in 6 hours, it makes sense that it's going to be less than 6 hours. And notice it's almost half, not quite though, because the other pump is doing the job slower, right? So the idea is combined together, it's reducing the faster one's time, but not necessarily by half if the other one's going slower, right? So it's reducing the time, 3.6 hours. Now, just a quick note, this work that we did over here on the rate per hour, you don't have to write that. This is enough work for each problem. Okay. But it's a good idea just to kind of go through the thinking of why we're doing this approach. All right. So let's try it again. This time we're talking about a roofer. And I'd encourage you, why don't you pause the video, try it yourself, see if you could do it, and then you can watch me do the work. But first I want to do is define my variable x. First thing, so I don't forget. So X is, again, since we have one roofer who does the job in 12 hours, the apprentice does it in 20 hours. How long would it take them to finish if they work together? So X is the time together. There's a T in front of that. Together. There we go. Okay, so there's my variable. Again, the work rates, I'm just going to list them out over here. So the rate per hour is going to be for the roofer, his rate is or her 1/12. For the apprentice, here I'm going to abbreviate that, apprentice, their rate is 1/20. Together, because that's the thing, I don't know the variable's x, that'll take them 1/x. So there is my rates to write my equation. So 1/12 plus 1/20 equals 1/x. Okay, so I need to find the LCD. Now, multiples of 20 are kind of nice. 20, 30, I'm sorry, 20, 40, 60. 60 happens to be a number that 12 goes into. So 60x would be the least common denominator. So that's what I'm going to multiply everything by. Oops, 60x. It wouldn't really be horrible if you end up just multiplying 12 times 20 and using that large number, 240. It would be fine. It can work. But I try to find the smallest one. That's the idea of the least common denominator, because working with smaller numbers means you tend to make less mistakes or less opportunities for mistakes. Okay, so let's reduce. 12 is going to go into 60 5 times. And that'll leave me with 5 times 1, which is 5, and an x. 20 goes into 60 3 times. And then 1 times the 3, oh, there's a plus. 1 times the 3 is 3, and an x equals, okay, so in the last one, x cancels, and I'm left with 60. All right, let's add that together. So that's going to be 8x equals 60. And then I'm going to want to divide 60 by 8. And just grab your calculator and plug that in. So 7.5. So definitely less than the first roofer, the 12 hours. Not close to half though, which kind of makes sense. I mean, the other one is working almost at twice as slow. The apprentice is almost twice as slow, right? Going to take almost double the amount of time. Almost. Okay, so 7.5 hours is how long it's going to take if they work together. That's how we kind of approach these work rate problems. The next type is these distance, rate, and time problems. Similar in the sense that we're still talking about rates, but we're also including the idea of distance and time. So we have a formula for distance equals rate times time, and often we abbreviate it using D equals RT. But I'm going to rewrite this formula so that it's just in terms of time. Time is calculated by taking the distance and dividing it by the rate. So that's what we're going to use for our problems. This is going to be our kind of formula that we're going to look at. So let's kind of look at the first example and see how this kind of plays in. So you and a friend ride bikes for the same amount of time. So you're both riding the same amount of time. You travel 24 miles and your friend travels 15 miles. So in other words, you're going faster. You're at a faster rate. Your friend's average speed is 6 miles per hour slower than yours. Makes sense. Let's find your rates. Okay, so here's what we're going to do. We're going to, I'm just realizing the cursor is kind of on the screen. It's kind of annoying. Sorry. All right, so we're going to write our variables. So they want to know your speed and your friend's speed. So let's go ahead and let X be my speed. So my friend is 6 miles per hour slower than me. So that would mean that whatever my speed is, I'm minusing 6. So that would be my friend's speed. All right. So there's my variables. What I have basically found are the rates for both of us. Okay, so let's use this information here. And what we're told is that that our time, that we're going for the exact same amount of time. So however long I'm traveling, my time is going to be the same time for my friend. So I can calculate time using this formula, the distance traveled divided by the rate. So my time, and here I'm going to kind of indicate that, my time is going to be my distance, which is 24 miles, over my rate, which is x. That's my speed. And that's going to equal my friend's time. Which is their distance of 15 miles over their speed, which we called x minus 6 since they're 6 miles per hour slower than us. So this is the equation I'm going to solve right here, that equation. Now, I can still use the same approach. I can find the LCD, which happens to actually, I'm just going to end up multiplying the two denominators together. And I'm going to go ahead and erase all this extra work here, so I don't need that on my screen. And I'm going to multiply by x times x minus 6, x times x minus 6. All right, so that's going to cancel x and leave me with 24 times x minus 6, which I'll distribute in just a second. Over on the other side, x minus 6 is going to cancel, and I'm going to be left with a 15 and an x. Okay, so let's go ahead and multiply the, distribute the left side here. So I'm going to get 24x minus, so in the calculator, that's going to be 144 equals 15x. All right, so I want to solve for x. I'm going to go ahead and move the 24 over, which should give me negative 9x. And 144 divided by 9 is going to be 16. Just plug it into your calculator. And they're both negative, yeah. Okay, so become positive. So 16 is my speed. So in miles per hour, that means that my speed, is 16 miles per hour. I'm assuming obviously miles per hour since we're talking about miles per hour. And then my friend, their speed is 6 miles per hour slower, so they're going 10 miles per hour. And that would be the answer. So the reason we kind of took this approach is we were given this phrase that it was done in the same amount of time. But yet we weren't given time. We were given their distances and an understanding between the two rates, a way of looking at the two rates. So that's why we kind of took this approach. Let's try it again. See if we can pull out the key phrases that kind of know that we want to take this approach. All right, so this one, you and your friend traveled to two different colleges. The two is spelled wrong. That should be TWO. In the same amount of time. There it is, that magic phrase. So that means we're going to use our little formula of distance over rate to set the times equal, because I'm assuming that's what they're going to give us. You drive 380 miles. There's my distance. Friend's distance is 400 miles. Your friend average speed is 3 miles per hour faster than your average speed. What is your average speed and what is your friend's average speed? Okay, so similar setup. We're going to start with our variables. So x, we'll just let x be my speed again. And then since my friend is going 3 miles per hour faster, x plus 3 would be friend's speed. I don't know why I wrote it backwards than what I've been doing it before, but there you go. All right, so there are the speeds, the rates. And now I'm going to take the rate. So my rate, we'll start with me, is, I'm sorry, my time to do it is going to be the distance, which is 380 over X. And then the time for my friend is going to be their distance, which is 400 over their speed, which is X plus 3. So we're doing distance over rate, the speeds. Okay, that's how we're coming up with this. All right, so LCD, X times X plus 3. By the way, you could, if you just ignore what I wrote in green and just look at what's in red on that equation, they have a technique that you could just do cross multiplying because you're just setting two fractions equal to each other and you just cross multiply. That would be a perfectly acceptable way of solving this. But I wanted to practice what we had done with canceling the common denominator like this. So I just figured we would take that approach anyways, just to practice. But it's the same technique. You'll get the same answer. Okay, so let's go ahead and write that out. We got 380 times X plus 3. If we cancel those X's over here, I'm going to get a 400. X. Okay, so let's get the calculator. 380 times 3 is 1140 equals 400. X. All right, so I'm going to minus 380 X to both sides. That's going to leave me with 20X equals 1140. Dividing that out, I am getting 57. So X was representing my speed. So my speed is 57 miles per hour. And then my friend's speed, they're going 3 miles per hour faster, so 60 miles per hour. And that would be the answer.